Welcome to the Illini Center. We're really excited to be in Chicago, hosting our critical conversation this year. The topic, as you all know, is balancing the intended and unintended effects of managing pests. My name is Madhu Khanna. I'm the Alvin A. Chacon Family Chair and Director of the Institute for Sustainability, Energy and Environment at the University of Illinois. This critical conversations is hosted by our institute. This is, I believe, the 7th or the 8th that we're doing in Chicago. And really the effort with this critical conversation is to bring diverse voices in the same room to share perspectives on a topic that is very complex, that has many sides to it and many different perspectives. And so this is one of those complex sustainability problems that affect agriculture in the Midwest. And we're here to listen to all the different perspectives and have you share your ideas and thoughts and opinions on this. As we get into the workshop tomorrow. Today, we're going to set the stage with a keynote address to sort of present the issues that we're grappling with, and then tomorrow we get into more of an in-depth conversation. So I'd like to thank you all for being here, for taking the time to join the conversation this year. Before we start the evening's program, I'm going to read our campus land acknowledgement. As a land grant institution, our campus has a responsibility to acknowledge the historical context in which it exists. We are currently on the lands of the Peoria, Kaskaskia, Piankashaw, Weah, Miami, Mascoutin, Odawa, Sauk, Meskwaki, Kickapoo, Potawatomi, Ojibwe, and Chickasaw nations. It is necessary for us to acknowledge these native nations and for us to work with them as we move forward as an institution with native people at the core of our efforts. It is now my pleasure to welcome Dr. Germán Bolero, the Dean of the College of Agricultural, Consumer, and Environmental Sciences, to the podium to say a few words to open this year's critical conversation. Dean Germán Bolero brings together a decade of administrative leadership to this role, having served as an Associate Dean for Research, head of the Department of Crop Sciences, and before that, faculty at the University of Illinois. He has been a member of the Gates family for nearly 30 years at the University of Illinois. He's an internationally recognized scholar in biometry and cropping systems. Dr. Bolero is also a celebrated educator and honored as a fellow of both the Crop Science Society of America and the Agronomy Society of America. His longstanding commitment to faculty, students, and communities continues to shape the global impact of the college as well as the university. I'm really delighted that he could be here this evening.
Thank you, Mario. I love this event. My favorite thing to do is just to interact with people and think this is a great event. I think the intention was to have the chancellor here to open this event. You have a cheaper version now. But I think the chancellor is very interested in issues of sustainability, and probably will see him participating in some of these events in the future. But thank you, Maru, and good evening, everyone. Welcome to this event. It's a pleasure to be here and to help open this year's iSEE Critical Conversations. I'm grateful to iSEE for convening this forum and for creating space for thoughtful, solution-oriented dialogue around some of the most difficult challenges facing food and agricultural systems today. At the University of Illinois and within the College of ACES, we approach these conversations grounded in our history and responsibility as we are a land-grant institution. So that responsibility goes beyond advancing research, but it means engaging with complexity, it means listening, and these events really help us with that, and it means connecting science, policy, and practice in ways that serve the public good. Few challenges reflect that complexity more clearly than pest management. I see a tremendous team here in that area. Managing pests is not optional for our producers. It is fundamental to protecting crops, stabilizing yields, and maintaining a reliable food supply, as well as protecting the environment. This discussion comes at a time when many producers are under significant pressure. Margins are tight, input costs are high, and uncertainty is growing. In that context, decisions around pest management are not only theoretical, they're practical, immediate, and deeply consequential, making conversations like this both timely and essential. At the same time, we know this decision shape more than immediate pest control. They influence long-term agriculture, resiliency, on-farm profitability, and local economies. They also have broader implications from ecosystems and pollinators to human health and geopolitical, and including our reliance on fossil fuel-derived inputs. Many of these effects are diffuse, difficult to measure, and hard to attribute, which makes them especially challenging to address. And this is not a problem owned by one group. Farmers, researchers, industry, regulators, policymakers, and communities are all part of this system. No single perspective holds the full answer. That is why forums like this one matter. Agriculture is deeply woven into our economy, our landscapes, and for some of us, our own identities. Decisions made here ripple outward across supply chains, ecosystems, and generations. Getting pest management right is not just about productivity today, it's about stewardship and sustainability over the long term. Progress will depend on interdisciplinary collaboration. It will require insights from agriculture, ecology, economics, science, data science, law, and policy. Just as importantly, it will require honest dialogue among stakeholders who do not always share the same assumptions or sit at the same table. iSEE's critical conversations are designed for exactly this purpose, by bringing together voices from across sectors and disciplines, and by creating a space for candid discussion. And these forums help surface common ground and identify pathways forwards that are both practical and durable. Across our campus, researchers are actively engaged in this question, examining pest pressure, resistance, ecosystem impact, and alternative management strategies. But like I said at the beginning, research is not enough. Impacts happen when knowledge is tested, challenged, and informed by real-world experience. That's why I'm especially encouraged by the range of perspectives presented here over the next 2 days. Your insights will help shape future research, inform policy conversation, and guide approaches that balance agricultural performance with environmental responsibility. I want to thank you again, Maru. I love working with iSEE. I love working with Maru and her team. I think that on our campus, interdisciplinary research is part of our DNA. And in our college, working with extension and listening to stakeholders is part of our DNA too. And we need to honor that on a daily basis. I also want to get off the script here for a second to say that this year we're celebrating 150 years of the Moral Clause, right? So for those of you that know the Moral Clause, is that little piece of land in the middle of campus. Now, it used to be the North Farm, by the way. I'm still claiming that part of campus in way for races. But what the Moral Clause represent for a lot of us is that long-term thinking and listening, and thinking about the future of agriculture, right? So we're in a year that we want to use it in ACES to think about that long-term thinking, investment. Sometimes we see the immediacy of doing things to satisfy something for the next 3 months or the next year. And I think the challenge for us in agriculture is to think, how do we send a message 30 years from now, 50 years from now, in terms of someone at that time thinking, wow, I'm glad they thought about that. I'm glad they had these critical conversations and they thought differently about the way that we do agriculture. So that's the challenge for us this year and every day in the college. The Department of Crop Sciences and a group are establishing we're talking at the table, the alma mater plots, which are going to be for the next 150 years. They're going to be a lot more complex and large. They have received a lot of feedback from stakeholders to issues like this. How do we do it right? How do we bring the opinions of many to research that would impact agriculture for the next 150 years? We've been around for 10,000 years in agriculture. We need to prepare ourselves for creating the education, extension, and research for at least 150 years and next in the college races. So with that, I'll stop talking and I'll call Madhu again. Thank you, Madhu, again. Thank you for being here.
So prepare us for a rich discussion tomorrow during this critical conversation workshop. It is my pleasure to now introduce our keynote speakers, Dr. Scott McArt. Scott is a leading voice in pollinator health and an associate professor in the Department of Entomology at Cornell University. Dr. McArt leads the DICE lab for honeybee studies and the Cornell Chemical Ecology Core facility, where his research focuses on how pesticides, pathogens, habitat, and management practices affect the health of both honeybees and native pollinators, an area where his insights have become foundational to farmers, beekeepers, regulators, and conservationists. Dr. McArt holds degrees from Dartmouth College, the University of Alaska, Anchorage, and a PhD in entomology from Cornell. Before joining the Cornell faculty, he completed a USDA postdoc fellowship at the University of Massachusetts Amherst. His lab continues to lead influential research in ecotoxicology, disease ecology, and plant-pollinator interaction, and really helps us understand and better protect the pollinators that sustain our ecosystems and global food systems. Beyond his research, Dr. McArt is widely recognized for his commitment to engaging with stakeholders and translating science into meaningful action. His talk today, titled Building Coalitions of Knowledge and Trust to Achieve Sustainable Pesticide Use in Agriculture, will get us thinking about what role we can play in creating information, building trust, and shaping policies relevant to pesticides, pollinator health, and sustainable agriculture. So please join me in welcoming Scott McArt.
Well, thank you so much for the invitation for coming here. Fun to look out and see a lot of familiar faces, new faces as well. Usually I give talks to a group of beekeepers or a group of farmers or a group of scientists or a group of regulators, but you appear to be all in the same room right now, which is pretty cool. So anyways, all right. So obviously the pressure is kind of high right now for trying to introduce a really complex topic. I will try my best. We'll see where this goes. So I thought I'd title this talk Building Coalitions of Knowledge and Trust to Achieve Sustainable Pesticide Use in Agriculture, because I think that's really what we're here to do, right? The concept of this is really cool. This iSEE group that has been meeting for apparently 8 years now. And I think this is really what it's about, right? So pesticides is a topic that I think all of you guys have navigated in various respects. A lot of people have very strong opinions on this topic, and oftentimes those opinions come into conflict. So how can we possibly build trust to navigate this particular situation? These are the stars of my talk right here. So all of these folks are, I would say, either majorly or mindfully involved in everything that I'm going to be talking about for the next 45 minutes or so. But I'm looking forward to hopefully building some coalitions of knowledge and trust with you guys as well for this next, day or two. All right, so to get us started, I thought I would Google why we're here. And I think this is really it, right? So we're living in the Anthropocene. When I Googled Anthropocene the other day, this is one of the first images that showed up, and I thought this really captures it, right? So we're on this world and we are having a major impact on this world. When you go a little bit step further than Google to Wikipedia, this is the first image that shows up or on the Wikipedia page for Anthropocene. And I think this actually really captures it quite well. So there's development, right? So we are in Chicago right now, in this beautiful city, looking out of a great view. But the elephant in the room is that big thing in the foreground called agriculture. That's how we eat, right? Some things that we do in development can influence agriculture. So, for example, climate change. But also agriculture really has this tension, right? So we have to do it well. We can't have food insecurity. But also agriculture is a major contributor to biodiversity loss as well, right? So controlling pests impacts the environment and it impacts us. One of the ways that we control pests is with pesticides. There's this tension between biodiversity loss and food security, and maybe human health as well. That's not my expertise, so we're going to be focusing on this aspect for this particular talk. So on the biodiversity side of things, we know that there are impacts of pesticides on biodiversity. My colleague, Melissa Guzman at Cornell, has one of the key papers on this right now. So what you can see here is taking all of the iNaturalist data for every single bee that's out there, 1,081 species, looking across the entire United States and saying, what are the major drivers of occupancy, declines in occupancy of those bees? And what we find, or what Melissa finds, certainly the royal we, what we find, is that pesticide use is the major contributor, okay, across a lot of things that went into this model. And it predicts the declines of 4 families of wild bees, right? So the bars over here mean those are declines in occupancy. Okay? There's a lot of other things that went into this model, but pesticide use was the major contributor. You guys also, there's some beekeepers in the room. You guys have also probably seen this a little bit more, but this is high honeybee colony losses that have occurred in the United States over the past 15 years or so. This became probably national attention. This is probably when a lot of folks started understanding this CCD, or colony collapse disorder, around the late 2000s and early 2010s. Well, CCD, that was average colony loss rates of around 30 to 35%. As you can see in red here, these are annual colony losses in the United States. It hasn't gotten better. In fact, it's gotten worse. Right? Last year was the highest recorded loss rates on record, 56%. This is not 100% due to pesticides, but pesticides are playing a role. Okay, so that's biodiversity and also a managed insect that potentially is experiencing some of the same stresses as some of the other organisms. How about on the farmer side of things? Well, farming is getting a lot more expensive. These are USDA NASS data for a 5-year period between 2017 and 22 in New York State. And what you can see is, on average, the cost of feed, fertilizer, lime, fuels, oils, hired farm labor, interest expenses, and yes, chemicals purchased has increased 34% on average. This is in New York State. And yes, one of those expenses is pesticides. Margins are really thin for farmers. I know we have at least 2 farmers in the audience. I'm guessing there's a few more. This is the story for New York in that 5-year time period. About 2/3 of farms are actually experiencing net losses. Right? One way that those thin margins are playing out is fewer farms. So here is at the national level, you can see a lot of red, and one state, Iowa, seems to be doing something good. With some green there, so that an increase in farms. The vast majority of farms or states are losing farms. In that 5-year time period, we've lost over 140,000 farms. 7% of farms were lost, potentially due to some of these thin margins. And I think this is, when we talk about pesticides, when money is tight, it is prudent to be risk averse, right? So if you're managing pests, well, you probably want to be sure that you're going to be managing those pests. This makes a lot of sense. I would be making the same decision. So how do we support farmers to adequately control pests while minimizing non-target impacts? Hopefully we'll figure that out. We're going to figure that out by the end of tomorrow, right? Okay. How do we navigate risk, information, and disinformation to build knowledge and trust? And yes, this is the kickoff. So yes, we're going to get a little spicy and we're going to talk about disinformation here as well. Okay. All right. So there's your introduction. I'm going to talk about 3 stories for this talk. I'm going to talk about one story that we have been involved in, my lab has been involved in for the past, going on, I think 8 years now, about government regulation for neonicotinoid insecticides. Then we're going to take a step in a different direction. We're going to talk about an industry initiative. So this is private industry that came to us and said, can we develop a reduced spray IPBM program, integrated pest and pollinator management, that's durable, that growers actually want? And then third, we're going to talk about a farmer or beekeeper concern regarding pesticide risk and then what's turning into resistance management is the story there. Okay, so 3 stories at sort of three different levels. All right, so let's start, and we'll start off with neonics because that's why a lot of people are here, I think. Okay, so in 2018, my lab was commissioned by the Cuomo administration in New York State to conduct a risk-benefit analysis for neonicotinoid insecticides. We poured our heart and souls into this. Travis Grout, an agricultural economist, took lead on this, and basically since then, I've been wanting to collaborate with economists on pretty much every single thing that we do. So we did a side-by-side benefit or risk-benefit analysis across all major application contexts in which neonics are used. So that's field crops, fruit crops, vegetable crops, ornamental turf and landscape management, and conservation and forestry. 432 pages later, and about 2 years later, we published this. And I'm going to give you the result, or one of the results, just right off the bat, and then we'll talk about how we got there. So New York is now the first state in the US to ban neonic seed treatments on corn and soybean seeds. This was signed December 2023, becomes effective in January 2029, which I think is very important to the story here, and we'll get at that. And then the other thing that I think is also really important to the story is it's a $2.2 million allocation to New York State IPM to develop and evaluate predictive tool for corn and soybean seed pests, and also neonic alternatives, right? All right, so we're going to get there. Let's go through the story of how we got there. Okay, so what did we do for this report? We did a giant review paper. Okay, so we compiled every relevant study that was published in the peer-reviewed and university extension literature. For risk to pollinators, this was 327 peer-reviewed studies, everything that was published up until 2020. And that includes exposure assessments and also toxicity assessments. And then for benefits to growers and applicators, for example, in conservation and forestry, we looked at more than 5,000 paired neonic versus controlled field trials and assessed impacts on pest populations, crop damage, and yield. Okay, so just a massive thing. This is why it took us 2 years. In most application contexts, there's surprisingly little data to make firm conclusions regarding risk. Okay, and that's something I think would be very interesting to talk about tomorrow. There's also clear economic benefits from using neonicotinoid insecticides in most application contexts. Okay, though alternatives certainly do exist, but that's not true all the time, right? So if you look at our risk analysis here for risk pollinators, I'm going to summarize it in one figure for you. So I only get 45 minutes to give this talk. And what I'm showing you here is impacts on 3 sublethal categories. So either behavior, physiology, or reproduction. Okay. And what I'm expressing here is exposures in and around field crops fields, as corn, soybean, and some wheat fields as a proportion of the LOIC. So proportion of the LOIC means the lowest observed effect concentration that has impacts on behavior, physiology, or reproduction. If you're above 1, by definition, that means there's risk in that particular category. If you're below 1, by definition, that means no risk. What do we find? Probably not surprisingly, there's not always risk, right? So some of those blue data points are below that red line, but sometimes there is risk, and those are the blue data points above the red line. The most important thing is right here. So 37% of the time around corn and soybean fields that are planted with neonic seed treatments, there's enough risk to impair or stop honeybee reproduction. Okay, that's going to have population impacts on pollinators. Okay, so why focus on neonic usage in corn and soybean? Here's a photo that I took a few years ago of corn being planted. I'm sure you guys have seen something similar like this, especially if you're from Illinois or the Midwest. Well, we know that 79 to 100% of cornfields and the majority of soybean fields are planted with neonic treated seeds in the United States. We don't know the exact number because no one's taking exhaustive data on this, but we do know it's a very high proportion, right? Up until 2011, you can see the vast majority of neonic usage in the United States is on that red and orange. So what is red? That's corn, maize, and orange is soybeans. These are the treated seeds. I know, and probably I'm talking to an informed audience here, and everyone knows what this is, but this is the treated seeds over in red here. Those have something on them, probably a neonicotinoid. Okay. So what happened? Well, in 2015, there was a dramatic reduction in neonic usage. Well, actually, that's not 100% true. We actually just stopped monitoring seed treatments in the United States, right? So you can see that very clearly right here, where all of a sudden we've had, again, 2015, we've dropped neonic usage, but no, that's not true. If you extrapolate out to 2025, you can draw a line through that, and it's somewhere up here, but actually, I have no idea where it is. No one knows where this is. Because our country currently does not monitor the major use of the most toxic insecticide used in the USA. Kind of crazy, right? Okay. Where do neonicotinoids go? Well, I'm very happy to say that this beautiful cartoon was actually produced by the gentleman right there. I use this in all my talks. Thank you, Christian. But only 2 to 3% of the neonic actually goes into the crop, right? So the neonicotinoid is shown in purple here, and here it is going into the crop. 2 to 3% is lost as dust during planting. So that's included in that plume of dust that's going out in that photo that you saw earlier. And 90% plus goes somewhere into the environment. It goes into soils, groundwater, surface waters, and potentially can move into lots of non-targeted things. For pollinators, the planting dust and non-crop flowers are the major exposure routes for neonicotinoid insecticides. Okay. All right. So coming back to this study again, I didn't mention this earlier, but actually it's not just pesticides that are strongly linked to wild bee declines, literally hundreds of species of wild bees that are declining in occupancy, but more specifically, it's neonicotinoids and pyrethroids. Those are the strongest predictors. And as you can see here we are in Chicago, more yellow means more neonicotinoid use right here in the Midwest via seed treatments, because that's the major use of neonicotinoids. This is the epicenter right here for neonicotinoid use and potential impacts, at least via seed treatments on these non-target organisms. Okay. There are major risks to bees from usage of neonicotinoid insecticides. So there must be major economic benefits to growers, right? Okay, so across all of these studies that we looked at, this is 613 field trials, everything that was published up until 2020 in either the peer-reviewed literature or university extension publications. What we find is that there's 2 different ways of doing controls here. You can either have a neonic treated seed versus a completely blank seed, or you can have a neonic treated seed plus the other treatments are on there, compared to the non-neonic but other treatments as a control. So that's why there's 2 pie charts here. But basically what we can see is a lot of gray. What does a lot of gray mean? That means that there's no difference in yield between the neonic treated or the plant that was planted with a neonic treated seed versus the control. Okay. On average, 12% of trials observe an increase in yield compared to controls. About 50% of those trials make up for the cost of the seed treatment. So yes, neonics do cost something. So that means that across all these studies, about 6% of farms benefit economically. Okay? In other words, about 94% of farms are actually losing money by using neonic treated corn seeds. The same thing is almost exactly true for soybeans. So about 93% of farms here, the prediction is that they would be losing money by using neonic treated corn seeds. Okay? All right. We actually know this is true because of things that people, for example, in the Farm Bureau say. So Colorado, I think some people in this room were probably on that call last week about a seed treatment bill that Colorado is currently considering. So here's an article published about it. Nearly every corn seed planted in Colorado is covered with an insecticide. Lawmakers may restrict the chemical. So Ashley House, the vice president of strategy and advocacy for the Colorado Farm Bureau, said, "We really see neonics and coated seeds as an insurance policy. They are an insurance policy, okay? And probably a very good insurance policy." Okay, so we synthesized this information, and my colleague, Julie Suarez, who's right here in the room, very happy to have Julie here with me, organized 27 meetings with about 200 policymakers, government officials, and staff over the course of 12 months. This was during the pandemic. A lot of it was on Zoom. Here's my Zoom photo. I had to take a photo of myself doing this because, my God, that was a lot of Zooms. I'm sure everyone here was doing a lot of Zooms during the pandemic. Here is also Julie with our governor, Kathy Hochul. Apparently, she's on hugging basis with Hochul, which is kind of cool. All right. I have to embarrass you since you're here. All right. So September 22 rolls around. And after doing all of this, this eventually comes to, all right, the state legislature would like to do something on this topic. So they organize a panel or a public testimony. Here is a picture of me testifying on this, trying to explain the results of this report, not just regarding field crops, also the others, but we're just talking about field crops for right now. Right before I got up to give testimony, this is what someone from the pesticide company Bayer said. So asked to comment on the Cornell report, they said it was incomplete in the absence of a defined approach. They just said there is the presence of a neonicotinoid, there must be an effect. That's not risk assessment, that's presence equals hazard. If that were the case, none of us would be drinking caffeine. Caffeine is 10 times more toxic to humans than neonics are, but we drink it every day. I have absolutely no idea what he's getting at with caffeine, but the important point is what's in yellow here, right? What is he trying to do? Well, he's trying to undermine trust in me. He's trying to say that hazard, that we just sort of defined, any presence of neonicotinoid is hazard. Here is all of the presence of neonicotinoids that are not hazard. Okay, it's not true what he's saying. It's not presence equals hazard. So this is not new, right? It was a little jarring at first. I thought, oh God, Scott's stepping out into the real world here, and there's people who are saying things that are not true. Really, the Bible on this topic is this book by Naomi Oreskes and Eric Conway. It's called Merchants of Doubt. Anyone in here read that book? Several. Great. If you haven't read it, I highly recommend it. If you don't want to read it, you can actually watch a movie about it on Apple TV or Netflix. They've made it into a movie. And really what this gets at is that this is the tobacco industry playbook. Okay. It's not just pesticide companies that are doing this. It's fossil fuel companies, and it started with tobacco, right? So how do we undermine trust in science and scientists to continue a product? All right. I tried my best to explain why this critique was unfounded, and I was unsuccessful. I think actually he was very successful in undermining trust. The Birds and Bees Protection Act failed in the New York State Senate in early 2023. In mid-2023, numerous legislators felt the bill needed another shot because it was based on sound science. And at that time, numerous op-eds started appearing in the media in fall 2023. So you thought the last one was spicy. This is going to get even spicier. All right. So an op-ed from Dr. Henry Miller appeared in the New York Post. New York farmers' futures depend on a single hopeful decision. Here's what it said. Activists led legislators with a single Cornell report from 2020 with serious credibility problems that implausibly concluded neonics are unnecessary. Its flaws included the absence of any new research, confusion about key concepts such as the difference between toxicity and risk, reliance solely on lab studies rather than real-world field data, and failure to understand the difference between systemic and foliar uptake. It also lacked any consideration of actual pesticide use patterns by New York farmers. Here is a picture of Henry Miller. I thought, my God, if I'm reading this guy, I have to find out who this guy is. He's a medical doctor. That's a picture of him with his poodle that I found on Wikipedia. So you don't have to go very far to find out who he is. Whoops. Oh boy, a little too far. So we approached the Post and said, listen, this is just factually incorrect. Can we publish a factual correction? We actually tried twice to the New York Post. They declined both times. At the time, I had a relatively large Twitter following. So Cornell suggested, well, why don't you post a response onto Twitter? So that's what I did. So I'm just going to read two things here, and then we'll finally move on from the spicy stuff, I promise. But here we go. Dear editor, a recent article in the New York Post by Henry Miller claims our report, neonicotinoid insecticide, etc., has serious credibility problems due to 5 scientific flaws, I'm writing to say that simple facts, which anyone can read by clicking the link to our report, discredit Mr. Miller's claims. We then go and talk about all of those things, including the almost 200 pages that we devoted to actual pesticide use patterns in New York State. There you have it, 5 supposed scientific flaws in our report, 5 succinct explanations why Mr. Miller's claims are baseless. The pesticide company Monsanto previously drafted an industry-friendly article for Mr. Miller to publish under his own name. One has to wonder if a pesticide company drafted this disinformation article for Mr. Miller as well. This was approved by Cornell Combs. Okay, why is that? Well, it's documented, right? So you don't, again, do not have to go very far. This is Henry Miller's Wikipedia page, and you can see that as reported by New York Times, Monsanto asked Mr. Miller to write an article rebutting the findings of the International Agency of Research on Cancer that it classified glyphosate as probably carcinogenic to humans, right? Okay, this is real, right? And I think the more I talk on this topic, the more comfortable I get to talk on it. It's a little uncomfortable of a topic, right? But the more comfortable I get talking about this, because this is a major thing that is going on in the world right now. It's not just pesticides. It's frankly quite a few things in the world. We should probably talk about that as well. But it certainly is relevant to discussing the things that we're going to be talking about for the next day or so. Okay. So what is the post op-ed ghostwritten by a pesticide company? I have no idea. But regardless of who wrote the article, its content, I think, makes sense if you consider economic benefits to industry, not economic benefits to farmers. So what are we doing? So coming back to, again, this relatively heavy-handed government thing that New York now has done and said, okay, we are going to restrict use of neonicotinoid insecticides. Well, how do we make that palatable? And how does that conform with, yes, there still are some benefits out there for the 6 to 7% of farmers that will actually benefit from having some sort of coating on their seed. Well, what we're doing is, again, this $2.2 million allocation to New York State IPM. Until January 2029, we're working with New York farmers to gain their trust on their farms, right? So we have 2-acre field plots on 80 farms throughout New York State. This is a 3-year study up until 2029. It's the largest neonic field trial that has ever occurred. And we're also developing predictive pest models and testing neonic alternatives. We don't want to leave those 6 to 7% of farmers out in the cold if they actually do need to have protection. That's important, right? What have we found? Well, we have 1 year of data, 80 farms. How many fields do you think benefited from using neonics?
None.
You got it. Not a single field benefited from using neonics. Turns out the science was correct, at least in year 1. We'll find out in year 2 and 3. Okay. And then I thought, oh, should I put this in? I'm putting this in. This is one of my, I think, most proudest professional moments up until this point in my career. So we've been doing a lot of work going out and actually being present at these field trials and having field days. One of them was, as you can see here, this past summer. I just want to read you this, and I promise I will stop reading emails. So, okay, here, Scott, this is, I just wanted to say thank you for coming to the Neonic IPM meeting in Hamburg, New York yesterday. I really enjoyed hearing from you and believe that your message about the pollinators needs to be heard loud and clear by our farmers, as I don't think they truly understand the threat that some of our modern agricultural practices pose on our pollinator populations. That is from a pioneer field agronomist who sells neonic treated seeds, okay? He then went on, I redacted the rest of it because I don't want to get into that, but he then went on to ask some actually really great questions, spark some great discussion about other topics that were very relevant. Okay. I think those are some really promising things that we're doing in New York. At least I feel like they're promising. But other states are considering this as well. Again, I know some of you were involved in the testimony in Colorado last week. There's extensive misinformation going on in Colorado. It's the exact same thing that happened in New York. The seed treatment bill similar to New York's was not passed. All right, so we'll leave there, and then we'll move on to not the heavy hand of government, but something that's actually driven by industry. this is the thing that I am currently most excited about. Okay, so the question is, can we develop a reduced spray IPPN program for a company? Who is that company? It's Keurig Dr. Pepper. I am personally just really gratified to be getting money from Dr. Pepper fees right now. But these are the two key people that are involved in this. So it's Whitney Caicos, she's the Director of Sustainability at KDP, Keurig Dr. Pepper. And then also Bill Abdo, he is the main guy at MOTS that we're working with. We are also working with the IPM Institute of North America that's based out of Wisconsin, but interacts internationally. Okay, so MOTS KDP approached us and said they're really interested in developing this, something to reduce risk to pollinators in apples. Apples are very different from corn and soybeans, okay? This is, first of all, they're beautiful. I love working in apple orchards, as you can probably see here. But also, they're economically valuable, so very high, economic value compared to corn and soybeans. They're pollination dependent. So corn, wind pollinated. Soybeans, yeah, it benefits a little bit from pollination. Apples, you don't have apples without pollinators, right? So very pollination dependent. And also they're intensively managed year round. A lot more sprays going on apples compared to corn and soybeans. And then I should point out, this is being mostly led, I would say, by Cheyenne Lindsay. She's a very talented PhD student who I have right now, excellent at science communication in addition to just doing the science. Okay, so what have we worked with MOTS and KDP on? We've really targeted three main active ingredients, okay? Neonicotinoids, we have an 80% reduction between 2023 and 2025 in the use of petal fall. So it's not taking away neonicotinoids like that heavy-handed regulation that we're talking about on seed treatments. Here it's just shifting the time when they're actually used. And they're being replaced at petal fall with indoxacarb, something that's a little bit softer on pollinators compared to the neonics. Avermectin, another insecticide, 85% reduction in use at petal fall between 2023 and 2025. That's been shifted to first cover. So not taking anything and replacing it, just moving the timing of it. And then pyrethroids, what we've seen is almost now an 80% decrease in all pyrethroid use between 2023 and 2025. That's throughout the entire season. And that was actually driven by growers. Growers were actually not necessarily asking for that, but very, very interested in potentially eliminating pyrethroid use. Okay. What have we seen? Wow, right? So this is just last year, our first year of comparing this IPPM program. This is in 15 conventional plots of blocks on farms and 15 IPPM blocks. And what we've seen is 36% more wild bees. Super cool, right? Apples are also 4% larger in the IPPM blocks. We need to get to yield, and we're not quite there yet. So I don't know if there's actually more production, but I do know that the apples are bigger, probably due to better pollination, because native bees are really important for apple pollination. And maybe most importantly, there's absolutely no difference in pests or pathogens. So in year number one of really taking systematic data on this, we've reduced sprays, we've changed timing, and we actually have no impact on pests or pathogens. So what does this mean? Well, I think this IPPM program may actually save growers money, right? You may have better fruit, reduced sprays, but also I think maybe more importantly, KDP and MOTS see this as an economic opportunity, right? This isn't just sort of, being green, being sustainable. This really is something that may actually make sense economically. Why? There's demand from consumers to be sustainable. Okay, so it could be really good for growers and for the company. Okay, so let's get into the social science of this a little bit. Is there actually less pesticide risk to bees? Well, actually, we don't know. Why? Because growers wouldn't let us sample bees for pesticide residues in 2025. This is sort of an ongoing discussion that we were trying to have with them. Why is that? Well, it's because of the Alar scare. Does anyone remember Alar scare? Okay, so you guys know, this is a photo of the 60 Minutes episode The Alar scare occurred in 1989. My goodness, growers have long memories, to say in 2025, we're not trusting you to select or look pesticides in bees because of Alar. What happened, it was a right-hitting agent, Dimetazide, that was suspected to cause cancer. They tested the apples and found Alar in there. There was a public scare from this, and $130 million of apples were lost from this particular industry that we're working with right now. A lot of pet folks had a really hard time staying in business during this. So understandable, right? So yes, we would probably find pesticides in bees if we go and test pesticides. I pretty much always find pesticides in bees when we go into agriculture. And they're worried that, okay, it could become a PR nightmare, not necessarily, something that would, obviously would really benefit the project if we knew that there was reduced pesticide risk to bees. But yeah, when you start dealing with the social side of things, it's very complicated. We're going to be talking about that tomorrow. Okay, second reason, here we go. A few key growers lost trust in Cornell in 2023 because a researcher asked them to sign a petition to ban neonic use in apple production. So for you scientists in here, I've been beating up a little bit on industry here. I'm going to beat up a little bit on scientists. You undermine trust in science by being an advocate, okay? Instead, if you're a scientist, build knowledge and trust. Don't become an advocate, because then no one's going to trust your science. Okay? All right, so we are working to build back trust in this particular system. We are going out and walking through their fields and catching bees, but we're also talking with farmers a lot. So Cheyenne is doing an excellent job at this. This is why I say she's really leading this project. Yeah, she's doing a great job scientifically, but she has the cell phone numbers of every single grower that we're working with, and she's starting to develop personal relationships with them. How do you build trust? You get to know people. Okay. All right. So there's the industry initiative. Let's wrap up with a farmer or beekeeper concern. And I know there's at least a couple beekeepers in here who are interested in this particular topic. Okay. So last year was the highest colony loss rate in history, recorded history in the United States. 56% nationwide losses. Here was something that a nonprofit group called Project APISM put out last year. Urgent, widespread colony losses reported. This is in California holding grounds. Every year, if you're not a beekeeper, you know that late January is the sort of the start of the beekeeping season for the vast majority of bees, because they go out and pollinate California almonds. We find out, a lot of the major commercial beekeepers find out how their bees are doing in these holding yards in California. And there were some, concerning things that we were finding out last year. So immediately USDA sent out Zach Lamas. So he was an ORISE, a USDA ORISE postdoc fellow, and he sampled 115 colonies from 6 large operations, sampled weak, medium strength, and strong colonies, beeswax, pollen, and mites. And mostly I put this photo up because Jay and Judy are wonderful. They're head of the USDA lab, and you never see them dressed up like this. Just like I'm almost never dressed up like this. So I just really like to have a picture up there. Okay. It got political really quick. So we decided that we would be willing to do the pesticide analyses on these samples. Here's an article from The Guardian. U.S. honeybee deaths hit record high as scientists scramble to find the main cause. U.S. Department of Agriculture calls a university to help study as Trump administration staff cuts state. Even a bad bee hunt in here too, right? God. Anyways, we got through that, and Angelica Sanchez, postdoc in my lab, ended up spearheading all of the pesticide analyses. How were we able to do this? Well, we run something at Cornell called the Cornell Chemical Ecology Core Facility. It's available to anyone. So if you guys, obviously many people in here are very interested in pesticides, that's probably why you're here. If you want to know what pesticides are in the tea that you're drinking, in the bees that you have, in the plants that you have at your farm, in the soils, in pretty much anything, send it to us. That's exactly why we exist. We do research projects, but we also do this from an extension and outreach perspective, just so people, if people are interested, they can find out. So we process about 2,500 samples annually. We were able to do this data set. So here's just some photos of Zach sampling again in these California holding yards. There's Andrew Garavito, another USDA scientist. I love this photo. I don't know who took this, but they were working day and night to do the sampling. I think they're in their pajamas here, pulling pollen out of these frames in a hotel room. And this is really, captures, I think, what they were finding. A lot of these colonies that were coming off of the trucks and the pallets had just dead bees everywhere. Okay, so you can see the dead bees scattered throughout the hives. Here's what it looks like on the bottom boards. If you pull the hives off, you can see a lot of dead bees down there. If you zoom in, there was a lot of these things. Anyone in here know what those are? Varroa mites. You got it. A lot of varroa mites in there, a lot of dead colonies. Okay. What Zach has found, and this is published as a preprint right now, I think it's just about accepted, talking to Zach a couple days ago. What he found is really high virus levels in all sample colonies across weak, mediums, colonies, even the dead colonies. High virus levels, and then also when he screened the mites for the amitraz resistant genes, he found that 100% of those mites had the gene for amitraz resistance. Okay, so again, high virus levels. When he purified the viruses out of some of these dead bees and dying bees and injected them into naive bees, it was really lethal. So more lethal than pretty much anything that those guys have done before. So clearly some very virulent viruses. And then regarding these mites, it was only 39 mites. If I had to go back and say, Zach, do 390 mites, not 39 mites, I would. But he looked at 39 mites across the 6 operations. And yes, 100% had resistant phenotypes. For those of you guys who don't know what amitraz is, it's the main synthetic chemical miticide used to control varroa mites. Right? So this is the main tool that beekeepers, a lot of commercial beekeepers especially, are using. Okay. So here is all the data for pesticide residues in heat map form. And what we found is widespread contamination across all samples. So up here, this is all the fungicides we found. This is all the herbicides, and here's the insecticides, and then especially red down here are all the miticides, including some of the amitraz breakdown products. Every single row is an individual pesticide. Every single column is an individual sample, and this is across the 6 beekeeping operations. So widespread contamination with pesticides. If you zoom in a little bit just on wax, you can see that wax is heavily contaminated. This is the most contaminated matrix of everything that we have here. On average, 18 pesticides per sample. Okay. We like to talk about individual pesticides. For example, the first part of the talk was just about neonics, right? 1 active ingredient, maybe a couple. The second part of the talk, 3 active ingredients. Well, the reality in the real world is that pollinators and other non-target organisms are exposed to a cocktail. There is no one single active ingredient. I think this figure right here really shows that clearly. Okay. But if we look at the concentration of all the different pesticides that are in there, it tells a slightly different story. So what we can see here is bees, all the different matrices, bees, pollen, wax, it's dominated by these dark blue, pesticides. What are those? 2,4-DMA and 2,4-DMTF. Those are the amitraz breakdown products. So that is basically amitraz. A lot of other things in here as well, but it's dominated by amitraz. You can then look a little bit further and incorporate toxicity information into all of the different pesticides that are in samples. So here we have good LD50 information, so lethal dose for 50% of honeybees when applied in the lab. If we look at LD50 in comparison to how much of any individual of those pesticides there are, you can compute something called the hazard quotient. And I'm expressing it here as a percentage of LD50 just to put it in biological terms, right? So if you're at 100% of an LD50, that means, that bee is experiencing an LD50. But we don't really find that much of that, right? So each one of these circles is an individual sample. And what we can see here is actually acute risk to bees is pretty low. There's a lot of pesticides there, but risk to bees is relatively low. For bees and pollen, it's about 0.1% of an LD50. And then for wax, that 18 pesticide matrix is about 2% of an LD50. Okay. All right. Now let's put that risk framework, right, the proportion of hazard quotient, and look at the particular active ingredients that are driving it. So what I'm showing you here is just bees, and what you can see is, again, it's really blue. It's mostly amitraz breakdown products. So I think there's two stories shaping up for this. This is one of them. It's amitraz breakdown products. And if you go back over here, remember it was 0.1%, right, of an LD50 that honeybees are experiencing. Well, if we make some assumptions and say, all right, what was a mite experiencing? Well, we know that amitraz is somewhere between 100 and 1,000 times more toxic to mites compared to bees, right? It varies by study, and it certainly is going to vary by, exactly what was going on in the hive at this time, but somewhere around 100 times or 100 to 1,000 times toxic. If we do the math, well, mites, if it was 1,000 times more toxic, they're experiencing about 100% of a mite LD50. This is just background and what's going on in these colonies. I would say that's kind of optimal selection pressure for the mites to evolve resistance to amitraz. What do we find? We found 100% of the mites had those resistance genes. Okay, so that's one story that I think confirms what we probably were seeing on the bottom boards of those six operations. But the other story is that it's not that simple. Okay, there really is a cocktail of pesticides out there. This is what's in pollen and wax. What's really driving risk in pollen and wax in these colonies? It's a cocktail of insecticides. It's avermectin, chlorpyrifos, spinosyn, diflubenzuron, fipronil, and spineterone. Okay, these are highly toxic insecticides to honeybees. When you look over here and say, okay, what's in wax? It's 2% of an LD50. Well, yeah, that's acute risk, but what about chronic risk from a cocktail of insecticides? We don't really know. Right? That's where science sort of stops and speculation starts. We don't really know what that is doing to bees that are living on this wax comb day in and day out. So that's a second take home. All right, now let's go to the social science side of things, and I'll wrap up with this. So 1 month after we sent these results to the USDA, I got something in my inbox, and it's a FOIA. Anyone know what a FOIA is? Freedom of Information Act request. And I thought, wow, well, this is interesting. So as you can see here, all right, the Dice Lab for Honeybee Studies at Cornell University College of Agriculture and Life Sciences, to the best of our knowledge and information, results of these analyses have yet to be reported. We want to see the data. Well, geez, guys, come on. We just finished the data a month ago. I don't know of anyone who actually, maybe there's other people in here who are faster than I am, but is there anyone who gets data in a month, analyzes it, writes it up, submits to a peer review journal, it goes through peer review and published in 1 month? Anyone? No. So I thought, all right, well, this is a big ask. And who's it from? Oh, well, it turns out it's an environmentalist group. So the Pollinator Stewardship Council is who put this FOIA in. So this was a little jarring. And I thought, well, God, what should we do about this? Well, I think the reason why this is occurring, and you guys probably see this, everyone sees this in the news nowadays, right? We don't have certain programs anymore in the government because trusted institutions is really low right now. Academia is an institution. USDA is an institution. I think that largely explains why we got that FOIA, right? So I thought, well, what can we do about this? Well, pollinator stewardship was out at the American Beekeeping Federation conference in January. And we said, well, how about we just get together and have some drinks and talk about the data, right? Sure, we could fight about this, but let's not do that instead of fighting. So we went out and had some drinks. We had a couple beers. We should do that right now if there's refreshments afterwards. I don't know. And we talked about it. We looked at the data and we actually talked about what was in the science just to try and build trust, to try and build a relationship. Here's what I got in the post drinks. I was given these two gifts, the Pollinator Protection Book and Vanishing Bees from the Pollinator Stewardship Council. Okay, so those are my stories. And then what I want to do is just finish up with trying to answer these two questions. So how do we support farmers to adequately control pests while minimizing non-target impacts? Again, I think we need to build coalitions of knowledge and trust. Hopefully I've given you some examples of where we're maybe successful, maybe still working on this. it's a work in progress, right? How do we navigate risk, information, and disinformation to build knowledge and trust? My personal opinion, it has to be done with humility by listening to all perspectives. That's what we're supposed to be doing tomorrow, right? And perhaps a little bit of humor, right? So some of these situations are just kind of humorous. People have very strong opinions on this topic. Let's laugh it off every once in a while. So here's my humor. Yes, everyone in this room really likes to talk about pesticides, but guess what? Not all rooms actually love to talk about pesticides. This is the last talk I gave at the American Beekeeping Federation conference. 2 people showed up to this. There you go. Okay, thanks very much, and happy to take questions if that's how we want to do it.